series. And a very special welcome today to our guest speaker, Leigh O'Brien. MSPC, our Multiple Sclerosis and Parkinson's Canterbury Charitable Trust, is a not-for-profit charity that supports people with MS and Parkinson's in the community. And we all need to hear about knowledge and advancements from research that can give us hope and help us reach a better future. And so the Keynote series is part of that we offer. Before we hear from Leigh, I just want to share some basic health and safety tips. The first is our emergency evacuation procedure. If something happens, please do evacuate in an orderly fashion through your nearest exit. For us, it could be the door that's over behind the pillar. It could be the door by the cafe area, or it could be the front door. So whichever is nearest to you, if you could exit through that, and then make your way to the car park, and we meet at the bike sheds. We have an attendance list, which we will endeavour to mark off at that time. So please hang around to help us mark you off. Of course, if it's an earthquake, just stay in your seat until the shacking's over. There are disabled toilets located just across the atrium and also just across from the gym. And if you have a cell phone, can you please make sure that these are on mute for the duration of this session. And question time, do you want to take questions during or at the end? Let's do questions at the end. It keeps it tidier, and that way we can hand around a microphone to people as well, so that everyone can hear the question. So now it's my absolute pleasure and privilege to introduce Leigh O'Brien. Leigh is a New Zealand registered dietitian who graduated from Otago University in 2003. She specialises in providing nutrition support for individuals with IBS and food intolerances, as well as clinical nutrition services for older adults in residential care. Leigh has a passion for research and practices evidence-based nutrition. She completed her PhD in 2023, investigating chronic diarrhea in older adults, and has contributed to multiple studies exploring the effectiveness of the low FODMAP diet in improving quality of life for those with IBS. Based in Christchurch, Leigh works as a consultant dietitian for Canterbury dietitians and dietary specialists. She enjoys helping individuals with functional gut disorders and supporting older adults in achieving optimal health through tailored nutrition strategies. The title of this keynote, which is up there maybe, You and Your Gut Microbiome, Nutrition for Health and Wellbeing. And during today, Leigh will help us understand how tailored nutrition can support energy levels and overall wellbeing for those living with Parkinson's and MS. So in this session, Leigh will explore the role of protein, the importance of gut microbiome, a food-first approach to support both you and your gut microbiome, and whether the latest dietary trends are right for you. Please join me in welcoming Leigh.
Thank you very much. Thanks for that warm welcome. Tēnā koutou, katoa, ko Leigh O'Brien, tōku ingoa. It's my pleasure to be here today. I really enjoy speaking at these events and talking to older adults about all sorts of things. And I guess today when I was asked to come and talk to you, I didn't really, I had a whole host of things buzzing around in my head, but in the end I settled on the gut microbiome, because it's one of my favourite subjects. And this is really a follow-on talk from a talk last year that was by Fiona Lathander. Dr. Fiona Lathander spoke last year. Her talk is on Facebook and is also on the Parkinson's and MS channel, website channel. Yes. And she's a researcher up in Auckland, a dietitian who does research in Parkinson's disease. And so her talk was really tailored around Parkinson's disease and talking about the latest research in that. And I encourage you to go and listen to it if you haven't done so already. So I'm just sort of building on what she talked about. So with Fiona's talk, she talked about nutrition research for Parkinson's disease, and she touched on some of the dietary trends that you may or may not have heard of. The keto diet, Mediterranean diet, and the protein distribution diet. evidence really in research today. There's a lot of information out there about different diets for people with Parkinson's disease, but actually when it comes to the crunch, there's not a lot of sound evidence. There does seem to be some favourable evidence towards the Mediterranean diet, and I hope that in my presentation I can kind of point to why that might be the case. She's working on some research looking at the protein distribution diet, and this is really around looking at the use of protein to help maintain and build muscle mass for people with Parkinson's disease. But actually, as we get older, protein is really important for all of us. But one of the things with Parkinson's disease is protein. When you consume protein at the same time as some medications, it might interfere with that medication. And so they're looking at some research where they're splitting the dose of having medications at a different time as having protein. So that's really interesting and quite novel research. We're looking forward to seeing some results from that. But really her talk was really fundamentally talking about the importance of eating a variety of foods. Definitely the importance of adequate protein and protein distribution. So by the time we get to around about 65, our body's not as good at absorbing, our body can still absorb protein pretty well, but we're not as good at getting the protein into our muscles. And so the recommendations are to try and spread protein throughout the day. So having some protein at breakfast, protein-containing foods at lunch, and protein-containing foods at dinner. So not relying on getting all your protein from just one meal. So the research that she is doing is looking at how that works when you're on some of the medications that interact with protein. And also Fiona touched on the importance or the fact that the gut microbiome can differ for people who have Parkinson's disease. And so that's where I want to take this talk. I want to take it that next step and talk about what's going on with the gut microbiome in people who have Parkinson's disease, but also with people who have multiple sclerosis. So we have many microbiomes throughout our body. We have a microbiome in our mouth, we have microbiome on our skin, we have microbiome in our brain, in our liver, in our lungs as well. But today I'm really focusing on the microbiome that's in our gut. So the microbiome that's in our gut is really impacted significantly by what we eat. One of the main roles that it does is it breaks down the food, and in breaking down the food, it's producing these substrates that we call short-chain fatty acids. So in the past, historically, we thought that the microbiome, the bacteria that was in our large intestine, really was just there to bulk up the stool. So this talk's going to be a little bit poo-based, so I hope you don't mind that. When you pass the motion, a lot of what you're passing is the dead bacteria, and it was always thought that that's great because it's helping with gut transit. But over the years, we've really discovered that the bacteria that lives in our large bowel has multiple functions, and it's incredibly important. One of the things that it does is it produces these short-chain fatty acids called butyrate, acetate, and pyranate. And we're going to talk about these a little bit as we go through the talk this afternoon. But just as a quick summary, butyrate is a substrate that, when it's produced by the bacteria, it's consumed entirely in the large bowel. So that means that all of the production of the butyrate ends up being used in the large intestine, whereas the other two end up circulating throughout our body and have important functions in the liver, various other parts of our body, and we also think that they have important functions with the brain as well. So what else do these bacteria do? Well, they're very important for breaking down food, especially fibre-containing foods, and they can make some vitamins. So they can make B3, B5 vitamin, folic acid, vitamin K. In fact, they're the source of most of our vitamin K. So also making vitamin C and B12. Very important for keeping the pH of the large bowel at the right level. So that the level of the pH in the large bowel is important, because if it's too high or too low, it can cause other bacteria that's not so favourable to start growing. And it can protect against certain cancers, including colon cancer. It can stop the cells growing or slow down the cells from growing. It's really important for supporting the immune system as well. and it's linked to several other factors such as mental health, reducing the risk of type 2 diabetes, obesity, and reduction in some cancers. So this bacteria that's in our large bowel is actually incredibly important for our well-being. One of the things about the gut microbiome is it's very changeable. In fact, it can change overnight depending on the diet that you're eating. When we're born with no bacteria, and then the way we're born depends on how much bacteria we start off with, and then what happens to us, particularly in that first 3 years of life, really sets us up for what our gut microbiome is going to be like for the rest of our life. So the exposure we have when we're little, whether we are breastfed or bottle fed, whether we have contact with animals, allowed to play in the dirt, allowed to eat lots of different foods, have siblings, all of these things contribute to what will become our unique microbiome. And our microbiome is unique to just us. It's like our fingerprint. Our fingerprint is unique to us, no one else has the same. And it's likewise with our gut microbiome. You will be similar to your siblings, to the rest of your family, but yours will be unique to you. So over our lifetime, the microbiome does start to change. So by the time we're 3, it's getting pretty much established. By the time we get to later age, and actually later age isn't really defined very well in the literature, we don't quite know what that means, but as we get older, the diversity and the amount of bacteria start to decline. And there's been some really interesting work around that. In particular, it looks like there can be some biomarkers for frailty. So there's particular bacteria that can grow in the large bowel when they're in large numbers seem to be associated with increased frailty. But we need more studies. As with everything, we need more studies. The reason why we need more studies, and the reason why a lot of this work is still quite association based, is because it's very hard to study. Because everyone is so different and unique, you need lots and lots of people to get some good information. There does appear to be some differences in the gut microbiome in people who have Parkinson's disease and MS. But again, not a lot of studies. But I just want to go through some of the studies with you and talk through some of the bacteria that may be different. So this is a piece of research that's looking at a lot of different studies combined. There are about 22 studies in this pulled together. And you can see here that there's a graph with the number of studies along one side and the types of bacteria along the bottom. And our orange lines, or orange-red lines, means that in people with Parkinson's disease, they have more of these bacteria than the normal control, than people who don't have Parkinson's. And the green lines mean that they have less of these bacteria than people with who don't have Parkinson's disease. So we have the family and then we have the genus. So I just wanted to point out some of them. So Lactobacillus and Akkermansia and Rhodella and Rosella and this last one are all different noticeably different in most of the studies that have looked at them to people who don't have Parkinson's disease. Now the interesting thing is that when we look at people who have got MS, we can see that there's also similar trends. So in this study, it was a study where they took, again, lots of studies of different people. The studies came from lots of different places around the world, from America, Spain, Italy, Egypt, Russia, China, Brazil. There were around about 570 people who had MS and around about 500 people who didn't, and they were comparing the gut microbiome of the two. And they found that similarly, there were differences in those same bacteria that were lower or greater for people with Parkinson's disease compared to normal control. So there's something going on. There's something going on with the gut microbiome when people have Parkinson's or MS. Don't know whether it's a chicken or egg. You develop MS or Parkinson's and your gut microbiome changes, or your gut microbiome changes and then that can lead on to an increased risk of becoming or developing MS or Parkinson's disease. So I just want to talk about some of the bacteria that are common between our two groups. So we have increased abundance, that means there's more than usual, of lactobacillus and akkermansia, and we have reduced, so less than normal, of Prevotella, Roseburia, and Faciobacterium. So let's just talk about them individually. I find them quite interesting. I love this kind of stuff, so if I'm boring you, I really do apologise. I'll get to some more food-based recommendations shortly. So lactobacillus, I'm sure everyone's heard of lactobacillus. It's one of the most sort of common bacteria that is often discussed. And usually it's considered to be really beneficial for the gut, for gut health. So we know that it's really important for keeping the lining of the gut really healthy. But one of the interesting things with it, it seems that it's one of those bacteria that too much might not be a good thing. So an elevated abundance may indicate a gut microbial imbalance or dysbiosis. And the problem with this is that when you have too much of one thing, it can compete for food for the other bacteria. So what essentially that means is they get greedy. So they're taking all the lion's share and not leaving food for the other bacteria, so the other bacteria don't get a chance to thrive. And with the gut microbiome, it's an ecosystem. It's like a community. So in a community we have our teachers, our doctors, our cleaners, our administrators. We have everyone that has a role to make that community really thrive. And it's the same in our gut. All these different bacteria all have a role, all do their thing, and collectively they keep you healthy. So if you get one who thinks they're a bit of a, the top boss, and they're getting a bit dominant and suppressing the others, that's never a good thing in any community, but particularly in our gut microbiome community. It's also the same with this bacteria, the akkermansia. So again, this one's considered to have some really healthy, beneficial properties. One of the things that it can do is it can keep the lining of the large bowel really healthy. So in our large bowel, we've got the muscle, and then there's thick layers of mucus that lead to the inside of the large bowel, and that protects the gut lining from getting degraded or breaking down. So the thicker the mucus, the better. That's what we want, really thick mucus. So this bacteria can lead to degrading that. It can lead to, if you've got it, it's really important to keep the mucus healthy, but if there's too much, it can overstimulate the mucus and it can start to degrade. And again, that can lead to what we would say is gut dysbiosis. Interestingly, this one is, because it is seen in just about every study to be increased for people with Parkinson's and MS, it's considered to be that it could be a biomarker for people with MS or Parkinson's. So what that means is that if you did a stool sample, which we'll talk about later on, where the stool sample that comes into play, but if you did that and this one was elevated, it could be an indicator that you have Parkinson's or MS before you develop symptoms. So that's interesting science. Where that takes us, not sure. And then we have the microbiome that are in lower numbers, so lower than normal. So Prevotella. So the important thing about this one, it again helps to keep the lining of the gut really healthy. And so this one we don't have a lot of when people have Parkinson's or MS. And so this bacteria is really important for keeping the lining healthy, but also it's one of the bacteria that produces those short-chain fatty acids, those substrates that are going through our body and doing other good work. So we don't want this one to be low. Interestingly, it also is associated with an increased risk of constipation. We know with Parkinson's disease in particular, constipation is a problem for a lot of people, and this bacteria, when it's in low numbers, may be making it worse. Maybe. Everything's a maybe when it comes to the gut microbiome. Another one where there's reduced abundance is this bacteria called Roseburia.
So this is a major butyrate producer. So this is another one that when you eat food, it breaks that food down and is producing the substrate called butyrate. And butyrate is super important. So when we don't have a lot of these, we're missing the opportunity to be making butyrate. So it's important for making the butyrate and keeping the immune system really healthy. And then the last one I want to talk about is the bacterium. This one it's one of the most abundant bacteria in our large bowel, so it accounts for, I think it's around about 3 to 5% of all the bacteria will be this particular one. It's really important again for making that butyrate, but also for keeping the pH of the large bowel at the level that it should be at. So what does this all mean? So why is the gut microbiome so important? As I mentioned before, it's really important for breaking down the food to produce these bacteria, to produce these short-chain fatty acids. So I guess what the research is telling us is that there's something going on that's putting you guys in a situation where your body might not be working from a gut perspective as well as it could be. So what can we do about this? Well, it's with everything when it comes to nutrition, there's no single superfood that's going to help. Despite what we might hear on the radio or read on the internet, there isn't a superfood that's going to help. What it comes down to is diversity. In fact, the more diverse your diet is, the better it is for the gut microbiome. In our gut microbiome, we have lots of different types of bacteria, and they all like different things. So some of them really like onions, some of them really like wheat, some of them really like apples, some of them really like another vegetable, broccoli. And so having a diet that's got lots of those, that has lots of different food in it, meaning that you're helping to feed all those different types of bacteria. So our plant foods are super important because they have the fibre that help to break down the bacteria break down to produce the good substrates, but they also have polyphenols. So polyphenols are our antioxidants and other compounds that our bacteria also like and do well when they have them. There is a little bit of evidence around fermented foods, so we'll talk about fermented foods shortly. It's pretty limited. There's some really good evidence that talks about excessive amounts of vitamins. So I think one of the things we need to be careful of is just not getting too caught up in any information that's trying to sell or promote vitamins as being the be-all and end-all. Because some of them our gut microbiome doesn't like in large amounts, in particular vitamin C, magnesium, zinc, turmeric. And also our gut microbiome doesn't really like high fat or high protein diets. So when Fiona was talking about dietary patterns for people with Parkinson's disease, she touched on the keto diet. So the keto diet is a diet that's really high in fat and low in carbohydrates. And some of the evidence around that is quite promising, but the long-term evidence for it has so there's lacking information on the long-term use of those diets. We know that they're pretty harsh on the gut microbiome because they're basically starving the gut bacteria. High protein diet, so this is meaning protein in excess really. So we're wanting people to be having some protein at every meal time, but not having oodles of protein, like protein shakes and protein upon protein upon protein. Yes, so their high dose protein and high dose fat is our gut microbiome does not do well with that. And in fact, it can produce it can feed other bacteria that could become too numerous and become too abundant. They can then have sort of negative impacts on the gut lining. So everything in moderation, but lots of fibre is, I guess, the bottom line. So fibre, let's have a wee chat about that. So fibre is kind of, the terminology around fibre changes all the time, as does a lot of other things in the nutrition field. soluble. So we really start thinking about fibre now more about its solubility. So is it soluble or not soluble? Meaning, does it, when you put fibre in water, will it break down or will it stay intact? So if it's insoluble, it's really good for lactation, or for not lactation, for laxation. So it's really good to keep your bowels moving well, to keep it regular. So the insoluble fibre, the grainy fibre, helps to keep your bowels moving nicely. Whereas the viscous fibre, so that's a fibre that when you put fluid with it, it will go into, will start to hold the fibre, hold the fluid, is really good for other reasons. So we then ask the question, does the fibre form a gel when you put fluid with it? And if it forms a gel, then we would say that it's really good for delaying gastric emptying, which means it can keep you full for longer. It's really good for helping to lower cholesterol, and it's really good for glycemic control. So for people with diabetes, it's a good type of fibre to include in their diet. All fibre is a good type of fibre to include in your diet, but you'll be looking at making sure you're getting a lot of that type of fibre. If it doesn't form a gel, then we would call it fermentable fibre. And it's the fermentable fibre that potentially has what we call a prebiotic effect. So prebiotic means that it's helping to feed the bacteria in the large bowel. So when we're talking about the gut microbiome, we're looking at the fibres that are fermenting. So we've listed them there. But really the consideration to be thinking about is that most food is a combination of different fibres. So even our grainy breads, which are predominantly more insoluble fibre, they will still have some viscous fibre in them as well, some fermentable fibre in them. How much do we need? Well, the recommendations are around about 25 grams a day, which kind of equates to about 5 plus a day of fruit and vegetables, and having some grainy carbohydrates as well. So something at breakfast, some all bran, muesli, wheat bix, grainy toast at breakfast, and then having some grainy crackers throughout the day, or wholemeal pasta, some brown rice. Those sorts of things are included as our grainy carbohydrates. How well do you think we do in New Zealand with that really basic recommendation of more than 2 serves of fruit and more than 3 serves of vegetables a day? Well, let's have a look. So this is data that's come from New Zealand. It looks at a cross-section of people who throughout different ethnicities, different socioeconomic areas throughout New Zealand, different age groups. And you can see from there that people who are over the age of 65 are doing pretty well. They're doing much better than a younger population. But one of the things we can also see, I'm just going to circle that, is that the percentage of people who are getting their 2 serves of fruit and 3 serves of vegetables has reduced over the years. So in 2011 to 2014, the data, the percentage of people achieving that was more than what it is now. So doing great, but not as good as what we were doing in the past, I guess is the message with that. Now if we look at our 15 to 24-year-olds, they're doing pretty crappy, aren't they? So only less than 20 of men are getting, less than 20% of men are getting their 5 plus a day. So how does adding more fibre look in our diet? How would it look practically? So I think the thing to do is just try to somehow incorporate it into your meals. So having some fruit at breakfast, for example, some salads, ingredients or vegetables at lunch, and again at dinner, and some snacks with some fruit or vegetables included in it. And of course, we don't want people to forget their protein or their calcium containing foods, because as we get older, calcium is really important for us as well. We need more calcium when we're older than when we're younger. So it's important to try and add those in also. So I just want to talk a little bit more around some of the other things that you might hear about in regards to the gut microbiome. In particular, prebiotics, probiotics, and fermented foods. Has anyone heard these terms before? Yeah, they're pretty much everyday lingo, whereas maybe 10 years ago people would be saying, what's a prebiotic? So your prebiotic are the foods that feed the bacteria. So they are the bacteria living in your large bowel. These are the things that feed that bacteria so it can produce those essential, those free fatty acids that acetate, butyrate and pyramide. It's a very individual, it's very hard to study because everyone is an individual, and so we have different rates in which these prebiotics are working within our large bowel. So the main ones are inulin, oligofructose, fructose, oh, spelled that wrong. Oh, spelled that really wrong. Might just go past that real fast. So they're added often into food by manufacturers, particularly inulin is added quite often, and then it's called a prebiotic food. But they occur naturally in a lot of foods. They occur naturally in legumes, so chickpeas, lentils, red kidney beans, baked beans, soybeans, just as an example. Naturally in grains, so oats, wheat, barley, rye, in some fruit as well, in some vegetables, and in some nuts. So it's not hard to get prebiotic food from the diet, from a varied diet. You don't need to be eating special prebiotic foods to get the prebiotics. Just a wee note on legumes. So legumes, I guess back in the 70s, you were probably considered to be a hippie if you ate lots of legumes. Whereas now it's kind of the mainstay of what dietitians and nutritionists are really promoting in terms of food advice. So legumes are a really important source of protein, prebiotic food of course. They're loaded with fibre and zinc as well. And the recommendations are to try and incorporate some sort of legume into your diet a couple of times a week. You don't have to be eating them every day, but a couple of times a week is a good goal to be aiming for. So legumes can be as simple as baked beans, or they can be a little bit more out there by sprouting your own. So sprouting your own mung beans or alfalfa or chickpeas. You can add these sorts of things into salads or even as a snack. Sometimes we can use legumes instead of meat. So making a vegetarian meal, for example, so making like a shepherd's pie with lentils instead of mince. Adding into soups and salads and casseroles or curries. Really good way of getting in some legumes over winter and added into a soup or casserole. Lots of food trends are lending themselves quite nicely towards having more legumes now. So Mexican food, Japanese food often use edamame beans, that's a legume. Indian food, so dal, for example, lentils is a legume. So try to find ways to just add a little bit into your diet if you're not already doing that. It's really good for your microbiome. And these are the sorts of foods that help, these prebiotic foods are the foods that help to restore some of the imbalance that may be occurring from these bacteria that seem to be in greater abundance or lower abundance. One of the things with lentils and legumes in general is if you add too much too fast, yeah, you know where I'm going with that, right? So if you have too much, it can cause a bit of bloating and really and a lot of gas. So when we get bloated and gas is happening, that's because the bacteria is fermenting those foods. That's what happens when the bacteria ferments those foods. The byproduct of the fermentation is gas, and that can lead to bloating. So for a lot of people that can be really uncomfortable and not nice. And what we would say in that situation is just very gradually bring the legumes in, so don't go crazy with them, but maybe just having, in a casserole, just adding in a quarter of a cup every so often. And over time, your gut microbiome will get used to or adapt to having those foods, and it will be less likely to produce the gas that's leading on to the bloating. But some people can be quite sensitive to them. So probiotics, has everyone heard about probiotics? Yeah. So probiotics are little capsules that in the capsules contain live bacteria, or their food which contains live bacteria. One of the things with probiotics is because they're a living organism, they have to get through your stomach and through your small intestine to get to your large bowel to make a difference. And that process of moving through the stomach and moving through the small intestine means that they're exposed to different levels of pH or acid. And that can just destroy a lot of the bacteria. So when you're looking at your bottles of probiotics, if you did want to get them, you want to make sure you get a probiotic that's got a lot of bacteria in it, because if you don't, they're just going to not make it. They're just going to die on the way. Poor little soldiers, they go to war and they just don't get there in the end. So around about only 0.5 to 5% will survive the transit of going through the gut. There is huge interferability between person to person on what happens to these probiotics when they get to your gut. So for some people, they'll work super well, and you're, whatever reason you're taking them for, which is the most important thing about probiotics, you need to be taking probiotics for a reason. Why are we taking them? Just for good gut health is not really a good reason. So for whatever reason you're taking them for, you need to know that they're making a difference. So we say to people, take them for a month, see if they've made a difference. If you think they've made a difference, keep them going. If you don't think they've made a difference, they probably haven't made a difference, so you're just wasting your money, so don't worry about them. The other thing about probiotics, as soon as you stop taking them, they stop working. So we used to think that the probiotics, when they got to your large bowel, when they got there, they would start to colonize the large bowel. So they would start to kind of embed themselves into the bacteria and start multiplying, and then you could stop taking them and they would just keep going. But actually, time has told us that that doesn't happen at all. So when you stop taking them, they just dissipate. But the substrates that they can produce can have ongoing improvements. So if you're taking them to prevent certain conditions, that can be long-standing after you've stopped taking the probiotics. I hope that makes sense. Made sense in my brain. I'm not quite sure it made sense when I said it. So one of the things about probiotics, when you go and just Google them, you'll probably see that they are the cure for everything. So whatever you have, there's a probiotic that's going to fix it. Well, the reality of that is quite different. So this little poster here, so cures diarrhea, helps your brain health, boosts your immunity, promotes heart health, supports weight loss. Well, the reality is that the studies to show that that's actually happening are pretty scarce. We do know that for some strains of probiotics, they could help to improve mild to moderate IBS. So for example, if you have bloating or diarrhea, there are particular strains that could help you. Some really lovely evidence around eczema in infants. So when the mother is pregnant with the baby, if she has a high risk of the baby developing eczema, there's a particular probiotic she could take that seems to be quite effective for that baby not developing eczema, but it needs to be taken when she's pregnant for that to have the effect. Really good studies around antibiotic use and for people who develop diarrhea and after antibiotics, that there's certain strains of probiotics that can help with that. There's some possible evidence around anxiety and depression and probiotics, but it's really in conjunction with other medications, so it's an adjunct. It can help is to add on some benefits. It's not going to do it in isolation. And there's some interesting research around specific probiotics and Parkinson's disease and MS, but it's very early days and those studies are very small. And one of the things we know about probiotics is we need a lot of people in the study to actually get some robust evidence, and we need long-term evidence, not just what's happened in the last month. So I would say that's crap. about fermented foods. Have we heard about fermented foods? Yeah, so fermented foods are another one of those really popular advertising ploys to get us to buy a product. So some fermented foods are also probiotics, so they contain living bacteria in them. There's such as yogurt, some yogurts. Sourdough is a fermented food. Beer and wine is actually a fermented food. Kefir, kombucha, tempeh are all fermented types of fermented foods as well. And actually these foods have been consumed for centuries, so they're not a new thing. Interestingly, I have this theory of my own. It's not proven, of course, because I've got no research to back it up. But I see in my clinic I have this cohort of people who come to see me who've come from other countries, usually Eastern Europe or sometimes South America as well, who after living in New Zealand for about 8 to 10 years, they've developed tummy problems, so lots of diarrhea or bloating, etc. And my theory around that is that they've just had such an extreme, not extreme, but their diet has changed from what they're used to typically eating. So their diets typically would have contained some fermented foods like pickled vegetables or different types of things like miso or kefir or those sorts of fermented foods that they've grown up with, and then they've moved away to another country and they're no longer eating those, and their gut microbiome is having a bit of a tissy fit, and it's not like the idea that they've taken away some of their food, and other types of bacteria have now started to ramp up and causing some issues. No proof on that, but I just find it quite fascinating. And so what I often recommend to those people is to somehow try to get back to incorporating some of those foods back into their diet. So it's very difficult to study fermented foods because there's so much variability. So one batch of kombucha, for example, might be very different to another batch of kombucha. And also, if it's gone through some sort of sterilization process, the fermented bacteria from the fermented food would have been destroyed. So it's not going to work. There is some evidence supporting the use of kefir. It's been the most widely studied, and it's the easiest one to study because it does seem to be a little bit more uniform. But I would say at this point,
what is kefir?
It's a milk drink that's made from grains that has fermentation properties in it. Yeah. You don't need a lot of it every day, but yeah, it seems to, and it would be made for people who are experiencing some bloating or their tummy just feels a little bit off. Yeah. So not really for things like preventing depression, anxiety, eczema, etc. So I guess where I stand on fermented foods is they're nice to include in your diet, but I wouldn't necessarily be wanting to buy them just with the thought that they're going to make a significant difference to your gut health. I think eating some food that comes from plants is probably going to be much more beneficial. So we've talked about diet in terms of that being really good for our gut, but it's not the only thing that's good for our gut. Diet is just part of it. So exercise, the things that are good for our heart and our brain and our muscles and our overall well-being, interestingly, are really good for our gut microbes as well. And when you think about it, that kind of makes sense because they're living organisms as well. So the amount of exercise we have has an impact on our gut microbiome, as does sleep. Sleep definitely has a big impact on the microbiome. Stress, without a doubt. We know that stress is a real killer for the gut microbiome. It can really unbalance it and make it, change things quite considerably. And smoking also does. It's been tempting to go, oh goodness me, what's going on in my gut? Is my gut okay? Unfortunately, it's very hard to study what's going on in your gut microbiome because our large bowel is large, so there's a lot of it, and there's different colonies throughout the bowel. So what we might find in the distal part of the bowel could be quite, or is quite different to what might be further up or the start of the bowel. So typically with stool analysis, they're just looking at what's going on in the last part of the large bowel, because that's what's survived so far. So there'll be bacteria that hasn't survived from early further up that they're not collecting. So you're not really getting a very good picture. The other thing is that there's huge variation between the commercial kits that are available, to the point where there's been some really interesting studies where the same person or the same group of people have given their stool samples to different kits to get analysed and then come up with completely different results. So who do you trust? Which one's right? Which one's wrong? And then the other thing is that our gut microbiome changes, and so I think what we really need to do to find out whether there has been a change is compare what it was maybe 20 years ago to what it is now. And that's probably the only way we're really going to know whether there has been a change in your gut microbiome. You're comparing yourself against yourself, not against other people. So my advice around stool analysis, even though there is a lot of on the internet, there is some really good selling for these kits. I just think they're a waste of time. In regards to resources, so Health Info, is everyone familiar with Health Info? So Health Info is a service that's provided throughout New Zealand, but it's actually run out of Canterbury. And what it is it's a one-stop place to get information about all sorts of medical conditions. And so when you go into Health Info, you just type in Health Info and type in whatever you're interested in medically, and it will give you a whole lot of resources that support that. So there's information on Health Info around Parkinson's disease, there's information on MS as well, there's information on healthy eating, all sorts of things. So it's I would say it's sort of the first port of call to find out just really good, reliable information, and it's reviewed regularly by experts in their field. And it's all evidence-based, of course. If you feel like you are struggling with your diet, if you've been losing weight or you're getting some significant gut problems, you could ask your GP for a referral to go and see a dietitian. Unfortunately, in Christchurch, we do not have enough community dietitians, and they are so under the pump, and unfortunately they're only limited to seeing people who basically have got being fed through tubes, so tubes through the nose or tube in their stomach. That's all they get to see because they're so busy. So unfortunately that does mean that you have to go private. If it's difficult for you to go private and you need to be seen by a dietitian, I think it's incredibly important that you are seen by a dietitian, so you could ask your GP to refer you through to the dietitians at the charity hospital, and that's a non-paying service, so you'll get to see a dietitian, you don't have to pay for it, but you have to meet their criteria to be eligible to be seen. If you did have just some basic questions or anything from today come up that you'd like to know a little bit more about, I'm very happy to answer any questions directly after this talk, or you're very welcome to also email me. I'm more than happy just to, if you've got a quick question, I'm very happy to answer that by email or point you towards a resource that could be helpful. So I guess just to finish off, we used to say you are what you eat, but actually you are what your gut microbes do with what you eat. So I hope you've enjoyed today's talk. Feel free to ask questions. Thank you very much for inviting me to come and talk to you today, and enjoy the rest of your afternoon. Thank you. Are there any questions? Oh, I might give you.
I'll hand it.
Oh, thank you.
Who's first?
And I have to say, there's so many things that we can talk about in nutrition, so I've kind of just been talking about some things. So I'm sorry if you've come expecting to find out something else about nutrition. I didn't mention it, so I apologise for that.
What is microbes?
What is microbes? So that's a very good question. So microbes is the collective name we give to the bacteria, the yeasts and the fungi that live in the different parts of our body. So today we'll talk about the gut microbiome, so the collection of all of those things. So they're living organisms, so they're the living things. And we have more microbes in our body than we have cells. So there's a lot of them, and we need to treat them right. So they're in different parts of our body. So on our skin, on our skin, in our bowels, in our lungs, we've got microbes that live there as well. Really interesting research looking around the microbes that live in our brain. So they used to think there were no microbes in our brain, but it appears that our brain has its own microbiome that's doing its own thing. So it's interesting. Lots of things are being found out about the microbes. Does that answer that question for you? Yes.
Leigh, look, thank you very much for a very interesting, informative talk. I just wanted to ask, do you know of any longitudinal studies that have looked at the gut microbiome over time and then looking at people who go on to be relatively normal and then those that develop neurological disorders?
Oh, that's such a good question. So the question was around the longitudinal studies. So these are studies that look at people over a long period of time and their gut microbiomes and whether that's leading on to neurological conditions. And I guess with that, no, there's not a lot. A lot of the information around the gut microbiome is very sort of snapshot. So it's looking at, this is what's happening now and not so much tracing people. So I think in time we will have that. One of the really interesting things that they have found though is that at any age our gut microbiome can change. So they've looked at people who are 100 and done studies on them to see whether how responsive the microbiome was to making changes, and it didn't take long for the microbiome to change. And then the other really interesting study they looked at was people moving into residential care facilities, and they found that before they moved into the residential care facility, their microbiome individually, for those people, were quite individual, but when they moved into the care home, their microbiome became quite similar. So the people living in the care home, their microbiomes were still unique, but there was more in common than when they were living separately. And we might think, oh, that doesn't sound very good, but actually it might be a good thing, because when they're living in the care home, they might be eating more fruits and vegetables and grainy foods and regular eating, and that might be promoting a good outcome. You don't know. There's so much to know, but we do know that things change. So I guess that's the take-home message from today is that it's not too late to make a difference. To increase more plant foods in your diet, and even increasing a little bit makes a big difference. Potentially.
Any other questions? No, just go to the first one on the side.
Do you have any information or help on if your colorectal area has been reduced considerably, if there is a change, or what will be the reaction to that?
That is such a good question. I do not have any information on that. So the question was around whether you've had surgeries in your bowel, what impact that has on your microbiome. It will have an impact. It will, but I don't know what that is. And I would imagine that's such a good question. I'd like to answer that, and I feel like I'm just making things up if I go ahead and answer that, so I'm going to leave it. But yeah, I would imagine it would. But to what degree? And whether the large bowel would start to adapt. Interesting.
Oh, sorry, we've got one over here first.
How does food intolerances affect the microbiome?
Yeah, that's a good question. So, and maybe the other question around that, the question was how does food intolerances affect the microbiome? But it may be how does the microbiome affect food intolerances? So, or create food intolerances, and what's the relationship there? So, food intolerance, the first thing to think about is that food intolerance means that your body, usually your gut, microbiome is not managing the food that you're eating very well, versus a food allergy, which is an immune response, so your body is allergic to that food. So generally, if something's happening in the gut, whether you're getting diarrhea, bloating, constipation, etc., increased gas, it's usually what we would say is a food intolerance, so that when the food's moving through your system and it's hitting the bacteria in your large bowel, the bacteria is producing more gas than usual. That is leading on to a whole array of other issues. So usually the bloating, abdominal pain, changes in bowel, either constipation, diarrhea, often fatigue, sometimes headaches, and that as well. So for a lot of people, they respond quite well to what we call the FODMAP diet. So the FODMAP diet is around taking out some of those prebiotic foods, the foods that we mentioned before that are really important for the gut microbiome. But the FODMAP diet, those foods in the FODMAP diet feed the gut microbiome, feed the bacteria, and it's feeding the bacteria that's causing the problems. So we take the FODMAPs out, but the really important thing to do is to do it short term. So we'd only ever do that for a month, and then we would start putting food back in to work out which of those things out of the foods you've taken out, which of those foods is causing an issue. And then what we do is we try and adapt the gut microbiome to it. So for example, some people might not manage onion or garlic. What we would do then is try and train the gut microbiome to get used to having onion and garlic. And we do that in adding in very small amounts frequently to allow the microbiome to adapt to it. Does that answer that question? I feel like I've gone off on a bit of a tangent there. So food intolerances, I guess, to bring it back to your question, is food intolerances is often due to the microbiome reacting to the food that we're having. So it's producing more gas or leading on to other symptoms.
I think we have time for one last question.
With the microbiome, is it done anywhere in New Zealand a transplant of someone with a good microbiome to someone with if you know you've got a bad microbiome or an absent one, to repopulate your gut?
Yes, so the question is around fecal native transplants. So this is where you take the bacteria from somebody who has a healthy bacterium and put it into somebody who is suffering something due to their large bowel bacteria being out of whack, basically. And whether that's been done and how effective it is. So that has been studied quite a bit for lots of different reasons. It's not, actually I don't know if it's done, there are places that do it in New Zealand, kind of under the radar, but in the hospital setting, it's used for people who have C. diff, so it's when they get a bacteria in their bowel that causes a lot of diarrhea. It's really, really hard to get rid of, and so it is very successful for that. They do it a lot in Australia and around the world. I don't know how often they do it in New Zealand, though, which was your question. The problem with fecal matter transplant is that you have to be super, super, super careful about who you're getting the bacteria from, because you're getting their bacteria, but you're also getting their genetic, some genetic matter as well. And so there's been some concerns in some cases in the past where somebody has had other things transplanted into them through the bacteria that's then gone on to develop something else. So it's can be a bit dodgy. So there has to be incredibly good screening around who your transplant person is. And the other thing with that is that you have to look after that gut microbiome, your new gut microbiome, and sometimes that
It'd be hard to feed it exactly like it should be fed.
Exactly, yeah, exactly. So there was a study, I know we've run out of time, but I find this really interesting. There was a study that Otago University did quite a few years ago. It was on TV. It was around using fecal matter transplants for people who were overweight, and so they were taking fecal matter from a lean person and putting it into a person who was overweight. Did anyone remember watching that? It was quite a few years ago. Yeah, it was really interesting. and so people were taking poo capsules basically. So it was encapsulated into a capsule, and you take the capsules, and then as it got to your large bowel, the capsules would open up, and you'd hope at that point, not before, and then it would start to populate your bowel. But the thing is, it didn't work. The bottom line was it didn't work. But the thing is, I think one of the reasons it didn't work was that they were not, the people they were getting the bacteria from, they weren't, the people who were getting the bacteria from those people, they weren't eating the same diets. So you've got the live bacteria, but you need the prebiotic food to help it take hold. So you've got to feed them right, yeah, and treat them right. All those other things, the sleep and the stress and the not smoking and exercise are really important as well.
And given the only way you can test a poo sample is by what comes out from the last part of the bowel.
Right.
And as you said, a lot of the bacteria have died, so you're only looking at a very specific number of bacteria.
That's right. So it's not a great way to test. Yeah, they can actually test the genes as well. So they're looking at the genetic markers that they left, but it's still not a very accurate test. So
that was a super interesting question to end on. Thank you for raising that. And what a fabulous presentation. Thank you very much. My favourite part was, well actually I had two favourite parts, if that's okay. First favourite part was that we all have a unique microbiome, like a fingerprint. And I wondered if you ever thought there might be a CSI program using the microbiome, for forensics. You heard it here first. I also like the idea of microbiome as a community and about how they each have a role to play. And I think that's a really great way to think about it, because like any community, like this community, we all have a role to play. And so if we can think about our gut in that way, it means that we want everyone to be happy in our gut. Every microbiome. So thank you very much. Thank you for coming and sharing that. I know from the interest in the room that we will be probably having Leigh back to talk about other things. She has already agreed, so hint for next year. And so as a part of our thank you, I'd like to give you some honey, which I'm sure is probably quite good for gut health. And because you've been talking so very long, some lozenges as well. And please join me with thanking you.